Okay, so in this part we will study about divisors. Divisors means a number which can divide a given number will be called as divisor. Okay, so suppose that we got a number n which is 375 357. Okay, it is 357 double zero. So let's do the prime factorization. So if you'll do prime factorization of this thing now, you will have 2 power 2, 3 power 1, 5 power 2, 7, 17. Okay, so suppose that this is the divisor D, which is having 2 power x. There are so many numbers, so I'll go with A, then 3 power B, then 5 power C, then 7 power D, then 17 power E. Okay, so look at the first question. We guys are interested in finding number of divisors. Okay, so required number. So suppose that n is being divided by D. So what do you think A can take, sorry, 2 can take power as? Do you think you can have 2 power 0? Yes. If 2 power 0, then it is 1. So 1 to it can divide na. A can take 1. Yes, because numerator is having 2 power 2. So if A will become 1, it is 2, which can divide, and A can also take 2. So for A, you have how many choices? You have 3 choices. Do you think your task is completed? No. So you have to multiply. Now think about B. What can be the value of B? It can be 0, it can be 1. So we have 2 choices for B. Now think about C. C can take 3 things, 0, 1, 2. D can take 2 things, 0 and 1. E can take 2 things, 0 and 1. So we got 72. So there are this many divisors are available. Okay, now look at this thing, the number of proper divisor. Okay, so in divisor everything comes, but in proper divisor you cannot take one and you cannot take the same number. Okay, so 72 minus 2, so it is 70. Now number of even divisors. Okay, so number of even divisors means if you will divide, the denominator should be even, correct? Now look at this. Now think about A. Do you think it can take a 0? No. If A will become 0 na, this thing will become odd. Okay, so A cannot take 0. Can A take 1? Yes. Can A take 2? Yes. So required number, A can take 2 numbers, B 0 and 1, 2, C 0, 1, 2, 3, D 0 and 1, E 0 and 1. Okay, so it is 48. Okay, now number of odd divisors, required number. So can I say that from all divisor subtract even divisor? So 72 minus 48. Okay, so can I say it is 22, sorry, 24. Okay, now you got some of no, sorry, all divisors. Now it's time to find out sum of all divisors. So look at this, how we will find sum. So required sum. So what you have to do, you have to write all the powers of 2 multiplied by all the powers of 3 while taking sum. So 2 can take power 0 plus 2 can take power 1 plus 2 can take power 2. So this is your 2 multiplied with 3 power 0, 3 power 1 multiplied with 5 power 0, 5 power 1, 5 power 2 multiplied with 7 power 0, 7 power 1 multiplied with 17 power 0, 17 power 1. So if you do the product of this thing, that will provide you the sum of all divisors. I hope till this part you guys are comfortable. Okay. Now look at this question. Find the number of divisors which are perfect square. Okay. So perfect square means the power should be even. Okay. Now think about 2 to the power. So do you think 2 can take power 0? Yes, 0 is yes. 1? No. 2? Yes. 3? No. So for 2 to the power you have two options. For 3 you can take 0, you can take 2, you can take 4. So it is 3 choices. Okay. For 5 you can take 0, 2, 4 and 6. So it is 4 choices. For 9 you can take 0, 2, 4, 6 and 8. So it is 5 choices. Okay. So 5, 4, 20. So it is 120. I hope the idea is clear. Okay.